aerospace and defense manufacturing,
machines and automation,
additive manufacturing,
smart manufacturing,
global manufacturing economy.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. If you haven't already, like and subscribe to get new episodes delivered to your inbox each week. I'm your host, Cary Gitter, Associate Editor at SME Media, and I'm joined today by David Muller, Senior Editor at SME Media, my colleague here. Welcome to the show. And so David had the opportunity to visit NAMRC, the North American Manufacturing Research Conference in Greenville, South Carolina, a couple of weeks ago, and also to attend the 2025 Blue Sky competition there. So, David, could we start by just talking a bit about NAMRC, what that is, what the conference entails, and sort of the overall picture of things there?
Yeah, absolutely. It was a great opportunity to kind of, it was my first time there at NAMRC, which, as you mentioned, is the North American Manufacturing Research Conference. And this year it was hosted by Clemson University, hence the location in Greenville, South Carolina, not too far from the university there, and a big BMW manufacturing plant in Spartanburg. It brings together academics, government and industry researchers, engineers, students in manufacturing from all over the world in a variety of areas, and really for a lot of kind of thought leadership and ideas of innovation. Really an interesting conference. And the Blue Sky competition was definitely a highlight for me personally. It was a really interesting aspect of the conference. It's the 8th year that they've done it now, and basically what it does, it awards visionary ideas that you might think as maybe being outrageous or radical, but are really are supposed to and already have in some ways informed the future of manufacturing. The competition is judged by a panel of industry and government experts. And the finalists, there's 6 finalists are chosen. There's, I don't know, a few dozen, maybe more submissions. And then 6 finalists were chosen, and they were flown down to NAMRC in Greenville, South Carolina, and they were each given 15 minutes to present to the panel of industry and government experts. And they really had these really kind of, and we can get into that in a sec, but these really abstract kind of high level ideas. And then anyway, so they present for 15 minutes, and then they have 10 minutes of grilling of where they kind of have to back up their ideas.
I see. Yeah, that sounds like a really fascinating setup. And so my understanding is that the winner of the Blue Sky competition receives the SME David Dornfeld Manufacturing Vision Award, and that's given out by the panelists there at the competition. So who was this year's winner, or who were this year's winners, and what was their entry, and what was it all about?
Yeah, it was pretty, I mean, they're all pretty interesting, but the winner, actually, the winning team, was from the University of Georgia, and their main theme was manufacturing empathy. And actually the full title was Manufacturing Empathy, Sensorial AI for Rewriting Human AI Collaboration. So now, basically, this team asserted that manufacturing processes overlook these crucial dimensions of empathy and psychological well-being in workers, and that can create blind spots in workplace safety and productivity, and then ultimately, if you're a business, it can affect your bottom line. And so this team kind of said, the current direction, as this is something that we well know at this point, and it gets kind of repeated on the show too, is that, manufacturing is going in one of two ways. One being that there's this, worker shortage, there's a bit of industry churn, and there's a lot of open positions, and there's a kind of looming skilled labor shortage. And then the other direction of manufacturing seems to be also going toward completely lights out, with no people involved in the production process. But so now this team from University of Georgia, which had some mechanical engineering students, said the human can still be in the loop, and they also talked about something they called the empathy gap, which currently is qualitative. You don't, there's not a lot of numbers to how are workers doing, or how are they functioning. So they want to turn it into a qualitative from qualitative to quantitative. Now they kind of acknowledge that, well, it wouldn't be too ethical to put a bunch of sensors on a human and do this kind of testing. So the next best thing is a robotic humanoid. So what they posit is like, okay, treating basically manufacturing empathy as a quantifiable resource and a strategic asset. Now, how would they do that? How would they gather the data on these humanoid robots? And you can probably guess that it has to do with artificial intelligence and sensors. So they basically they'd launch emotionally intelligent humanoid or quadruped robots equipped with multimodal sensors that parallel or in some ways they argue even surpass human senses. So think like visual perception with high resolution optical systems, tactile sensitivity, so like sense of touch, which could measure precision load and pressure and even thermal arrays, auditory acuity, which would include microphones with emotional analytics, olfactory detection using chemical and particulate analyzers, and finally, last but not least, basically taste recognition with microfluid sensing. These are the kind of ideas that are at this, and this is the winning. This, of course, is the winning submission. So then, anyway, the kind of taking this as a altogether, they argue that this could kind of push beyond traditional perception on the shop floor and into kind of really getting more insight into what workers are faced with, and also learning from it and creating a better workplace.
Wow, yeah, that's so interesting. So the idea would be that with all these capabilities and sensors, the robots would actually sort of be learning from and taking their cues from the humans and then adjusting their behavior accordingly to work more successfully together. Is that kind of the gist of it?
A little bit. Yeah, I think a little bit more, it would start with the robots themselves kind of performing some of these tasks and gathering data. And actually, that reminds me of an interesting question. I mentioned, like after the presentation, there's a bit of a grilling period by the industry and government experts. And one person asked, how do you measure, all people are all different sizes, different workers are different sizes. So how do you get an accurate measurement for everybody from one robot? And they kind of said, well, we start with a baseline with that particular humanoid robot, and then we can learn from there. But just, kind of it's all about obviously gathering data and then what you do with the data and what you can do with the data. And AI obviously is informing that and advancing that by the day. And another part of their proposal to that effect was and to mention, just on the note of this potential brain drain that manufacturing sector faces with all the, people potentially retiring and their jobs not getting filled, is part of the proposal of this team at the University of Georgia was to use what they called intuition transfer algorithms that encode and embed retiring experts' tacit knowledge into next generation systems. So you preserve their what some people refer to as tribal knowledge and expertise, and then kind of use that to inform all the data that they can kind of inform their manufacturing process with. It's a lot.
Yeah, that would be a really impressive achievement if that were put into practice. And were there any other among the 6 finalists, any other projects that caught your attention or that were particularly noteworthy or impressive?
Yeah, I mean, they were all pretty impressive. Like a couple come to mind right off the bat, though. I mean, like for one, a PhD candidate from the University of Texas A&M had a presentation on what he called symbiotic manufacturing, and he focused on agriculture and kind of talked about how natural systems really kind of work in symbiotic ways, and manufacturing, even in like for like the agricultural sector, should do that because it hasn't adapted. Like there's been technological advancements in the agricultural sector, but there's just like there are living, breathing organisms in nature, so too could like these different aspects of agricultural processes be, manufactured to kind of intelligently respond to what the needs of like a farm basically or an operation would be. So they called it what they called it. The notion is spatially intelligent agents. So which would be inspired by agents in nature like wasps, birds, ants, and bees that kind of build their homes based on simple axiomatic principles rooted in dynamic manipulation and management of personal and shared spaces. And then they kind of interact with each other in that way. And then so too should these different processes in agricultural manufacturing do that as well. But one of the other, I think maybe I don't want to say favorite, but another one that really stuck out was there was a presentation on 3D printing in space by a master's student in mechanical engineering at Carnegie Mellon. And he did a presentation. It was actually on, he called it in situ 3D printing in space, in situ meaning, done in place, done on site. And, some of the challenges of 3D printing in space, 3D printing in space would be useful for probably maybe obvious reasons. If some kind of part goes down on a vessel or whatever you need to repair, you could maybe 3D print the component right there and not have to wait for, the part to come up to space and meet you there or whatever. Anyway, but the challenges with 3D printing in space is there's microgravity effects. There's different kind of weight considerations. So anyway, this team from Carnegie Mellon proposed developing an advanced additive manufacturing process that actually leverages basically moon rocks and Martian regolith as feedstock. Martian regolith, and hopefully I'm pronouncing that right, regolith is the loose, unconsolidated material that covers the surface of Mars. Basically like the stuff that makes Mars red. It's like the dust, broken rocks, and soil. And then that is like iron-rich rocks that are similar to basalt that, like I said, that's what makes Mars red. But anyway, this team proposed using high energy techniques to reduce the material to basically this fine particulate state. And then they'd use magnets or electrostatic filtering to remove contaminants from the particulate. And then the refined powder could be used for thermally driven processes such as sintering or directed energy deposition. So, I mean, if it was pretty wild to think about and to kind of imagine.
That's funny. That kind of reminds me. Recently, I was reading a story about the Army developing 3D printing capabilities for ice to be able to build basically like ice-based structures in cold regions where they're deployed, where they don't have access to conventional building materials or methods. And the natural environment there is ice, and that could actually be used to build structures that they could be housed in and used for other purposes. So it's kind of, whether it's like a cold region or a space surface, it shows that like additive manufacturing can really be utilized in some pretty innovative ways with whatever like materials are available in that particular environment.
That's fascinating. And that kind of goes to show that some of this stuff is, as organizers have asserted, and I'm going to talk about that a sec too, actually, like some of this is not so far off. And the goal of this competition, while some of it may kind of sound like otherworldly or maybe not like a tomorrow kind of thing, I mean, it wants, this competition is aimed at kind of informing what you think maybe the new textbooks, the next courses in manufacturing and advanced manufacturing, mechanical engineering are going to be about. I spoke with Michael Seeley, who's an associate professor in the School of Mechanical Engineering at Purdue University, and he was one of the organizers of this year's event. And he kind of noted that, some of these past competitions have led to real world results. He pointed to a 2018 competition where there were ideas around human and robotics integration, kind of like a little bit like what we heard about, from the winners this year. And it translated into NSF research centers. I mean, there's been ideas from the Mayo Clinic around bioprinting inside the human body that has translated into real things happening in operating rooms. So, and even he said White House policies have come out around in-space manufacturing, so that has been floated from previous competitions in this blue sky competition. So yeah, I mean, it's and actually he himself, Professor Seeley, presented an alternative protein back in 2022, and today the largest cell center in the country is now led by someone in the manufacturing community out of NC State. So it's really cool stuff, but it also is stuff that leads to real world results.
Yeah, that's really cool to hear how these things can be implemented in actuality and go beyond just the abstraction. Before we go, I have to ask you one last question. I noticed one of the finalists, it's called Music-Inspired Autonomous Nanofab Platform. I don't know if you were there for that part of the presentation, but what is that referring to? That sounds so intriguing, a music-inspired entry.
Yeah, it was. I mean, and he actually played a little bit of guitar music and things like that. And it actually, this presentation centered around the semiconductor manufacturing, and he kind of the presenter was from State University of New York at Binghamton. He kind of noted that semiconductor manufacturing is centered around large, highly specialized fabrication facilities that require these multi-billion-dollar investments and obviously coordination for a lot of logistics and things like that. And they also may rely on a few key global suppliers, which makes the supply chain fragile. I mean, anybody who remembers what happened in the COVID era, I mean, the semiconductors, I mean, the United States almost started frantically trying to build semiconductor facilities stateside because so his idea was to address kind of some of these challenges. His research team envisioned a nano fabrication platform with AI driven autonomy, which would be kind of this decentralized and flexible alternative that it complements conventional semiconductor manufacturing kind of by using smart acoustic emission is what he called it. An acoustic emission he referred to just as the acronym AE. Which would be sensing, monitor nanoscale dynamics, and achieve autonomous fabrication. I guess, basically, as existing high precision inspection relies on vision-based methods like optical and electron microscopy, but their approach shifted toward like a listening paradigm where they'd kind of leverage sensor signals to capture nanomachining interactions in real time.
Well, David, it sounds like you had a really eye-opening experience at NAMRC and saw a lot of really cool, innovative work going on at the Blue Sky competition, some of which may, in the future, be resulting in real-world applications that we'll be seeing down the road. So, yeah, thank you so much for sharing some of that with us today. It was great talking to you.
Yeah, thank you. No, I'm happy to share. I appreciate it.
And to learn more about the latest manufacturing trends and hear more podcasts, you can subscribe to our podcast feed. And of course, visit us at SME Media at advancedmanufacturing.org.